All right, today we looked at a new kind of reaction called a precipitation reaction. Okay, a precipitation reaction is a type of double replacement that results in a precipitate. Precipitate is a solid. Now, the interesting thing about this is that you can have two solutions with stuff dissolved in them coming together to produce a solid, which is what we're looking at here. So I'm going to give you an example of one. We have, and this is not one that we did in class, SRBR2, and we have these letters AQ next to it, plus K2SO4, also with an AQ, yields SRSO4, which has an S next to it, and KBR, which also has an AQ next to it. First thing that you should notice is that this is not a balanced equation, and I think the only thing that we actually need to do to balance this equation is to add a 2 for the coefficient here on potassium bromide. Now, these letters on the side, this AQ, this means aqueous. It means that this strontium bromide is dissolved in water. It means that this potassium sulfate is dissolved in water. And it means that this potassium bromide is also dissolved in water. This S is a solid, so this is our precipitate. So in our precipitation reaction, this is the product that we have made, is the strontium sulfate. Okay. Now, the interesting thing about a precipitation reaction is that we can then look at total ionic equations and net ionic equations. The reason for that is when you see aqueous solutions, and that's a little redundant, but when you see compounds that are aqueous, that means they are dissolved in water. And ionic compounds, in general, if they're dissolving in water, they will dissociate. That means that they will dissociate into their respective ions. So if you look here, you should be able to figure out which one is the cation, which one is the anion, and what the charges are. So strontium is going to have a +2 charge. It's in the alkali group. Sorry. I'm sorry, it's not in the alkali. It's in the alkaline earth group, so it's a +2 charge. And bromine has a -1 charge. So Br with a -1 charge. And notice that you have 2 bromines. So you have to say that in addition to the 1 strontium ion, you'll have 2 bromine ions. Okay? Plus, now this has dissociated, but since potassium sulfate is also aqueous, this is also going to dissociate. Potassium has a +1 charge. Notice there are 2 of them. And sulfate has a -2 charge. So SO4 has a -2 charge. And that yields these products. Now, here's the thing about the solid. If it's a solid, that means it is not dissociating in water. That means that you leave it exactly the way it is. And here you have potassium bromide that does dissociate. So you have, notice you have 2 potassium ions and 2 bromine ions. Okay, so this is your total ionic equation. All right, your total ionic equation has all of the ions, broken down because they have dissociated in water. Now, the interesting thing here is that if you look carefully, some of your ions are the same on your reactant side as they are on the product side. So you have 2 bromine ions here and 2 bromine ions here. So we'll just mark those. You also have 2 potassium ions here and 2 potassium ions here. Mark those as well. Of course, you have a strontium ion, but here it's not it's not dissociated. It is part of a compound. So it's not the same on the product side as it is on the reactant side, and the same is true for the sulfate. You've got a sulfate ion here, but here it's not in the ion form, it's in a compound. So all of these that I marked with the star are called spectator ions. It means they're not really participating in the precipitation reaction. So when we write our net ionic equation, we ignore the spectator ion. So everything that has a star next to it does not get included in our net ionic equation. So what's left is our strontium with a +2 charge and our sulfate with a -2 charge, and that yields strontium sulfate. This is your net ionic equation. All right. Now realize that most of the time I will give you only the reactants and ask you to predict the products, and you should be able to do that based solely on the fact that this is a double replacement reaction. You will also need to balance the equation, because if it's not balanced, then you're going to be missing some of these important numbers. You're going to need to be able to do the total ionic equation followed by the net ionic equation. Okay, so let's do one more example so that we can walk through all of the steps again. Okay, so I'm going to look at CrNO3, and this is aqueous, forgot to write it in, plus FeSO4, also aqueous, yields FeNO3 2 plus Cr2SO4 3. Now, something I haven't gone through in the video is how to determine which of these products is the precipitate. So that's something that you're going to use your solubility rules for. Excuse me. So on your reference pages, and I know it's very small and you can't see it, but you can refer to your own at this point, you have solubility rules. Here you have iron 2 nitrate. There's going to be a rule here that will tell you whether this is going to dissolve in water or not. So all nitrates, and I'm just looking at the first one, all nitrates, acetates, ammonia, and group 1 salts are soluble. Okay, well that's convenient. So that means that it is aqueous. Here we have chromium 3 sulfate. Okay, so now we're probably going to look for something that has sulfate in it. And here it says all sulfates except calcium, strontium, barium, mercury, lead, and silver. That doesn't include chromium. So all sulfates are soluble. So this is also aqueous. So something to notice here is that you actually don't have a precipitant here. This is not a precipitation reaction. However, I may still ask you to write out the total ionic equation and the net ionic equation for these. So let's figure out how to do that. Again, first realize that this is not a balanced equation. So I'm gonna put a 2 here since you have 2 chromiums here. We'll make 2 there. Now we have 6 nitrates, so I'm gonna put a 3 in front of this iron. And now I have 3 irons here, so I'll put a 3 here. That gives me 3 sulfates and 3 sulfates, and that is balanced. I know that was fast, but if you can't follow that, then you need more practice balancing equations, which there's plenty of practice available for you. All right, now from there we can go ahead and write our total ionic equation. So all of these dissociate, so make sure that you are breaking all of them down into their ions. Chromium is going to have a +3 charge. Okay. And that's simply based on the fact that there are 3 nitrates bonded to this chromium. Notice there are 2 chromiums. So 2 chromiums with +3. And now we have NO3 nitrate with a -1 charge. Now notice you have 3 nitrates times 2. So your coefficient here is actually 6 nitrates. So for every 2 chromiums, you have 6 nitrates. And now we have iron. So this is going to be iron with a +2 charge. And notice you have 3 of them. So that's 3 Fe +2. And 3 sulfates. 3 SO4 with a -2 charge. And that is going to yield, again, 3 Fe +2. Notice that the charge on that iron did not change. It's always going to be true. The oxidation state for a metal is not going to change from the reactant to the product side. We also have NO3 with a -1 charge. And how many do we have? We have 6 of them. That we have 2 nitrates for every iron 2 nitrate, and there are 3 of those compounds, so that's going to result in 6, plus 2 chromiums with a +3 charge, and 3 sulfates with a -2 charge. Okay. Now, this was kind of a lot, so pause it, rewind it, and make sure that you can follow where I got all of these. Okay, realize that these 2 are from our first term right here. These 2 are our second term. These 2 here are from the third term, the first of the products, and these 2 are from the fourth term. Okay, now I want you to write the net ionic equation. Now remember that everything that is the same on the reactant side as it is on the product side does not get included in the net ionic equation. So let's look at this. We have 2 chromiums with a +3 charge here and 2 chromiums with a +3 charge here, so those are not included. We have 6 nitrates here and 6 nitrates here, those aren't included. 3 irons here, 3 irons here, those aren't included. And 3 sulfates here, 3 sulfates here, those are not included. So what happens when you have nothing left for your net ionic equation? You write no reaction. And what that means is that there's no reaction visible, right? So you have put these 2 solutions together, and you were hoping for a precipitate, something to come out of solution as a solid, but both of the products are also aqueous. They are also soluble. They dissolve in water. So you really didn't get anything except for an enormous amount of fluid with a bunch of dissolved ions, very many dissolved ions in it. So your net ionic equation is no reaction. And hopefully you realized that something funny was happening here when we first looked at both of these and saw that they were both aqueous. Neither of them was the precipitate. Okay, so we'll do some more practice problems in class, but make sure you take a look at the practice problems that are suggested on the website and try some of them tonight.